Welcome to Dr. Mercola's Cellular Wisdom. Stay informed with quick, easy-to-listen summaries of our latest articles, perfect for when you're on the go. No reading required. Subscribe for free at mercola.com for the latest health insights.
Hello, and welcome to Dr. Mercola's Cellular Wisdom. I'm Ethan Foster, and in today's episode, we'll examine newly published research that shows how psychological stress can reprogram the gut's immune memory, turning formerly harmless foods into triggers for irritable bowel syndrome, or IBS.
Thanks, Ethan. IBS disrupts the routines of roughly 10 to 15% of Americans, bringing bloating, cramps, constipation, or diarrhea without any visible injury on scans. We'll clarify why that disconnect exists and how stress-primed immunity explains the day-to-day unpredictability of symptoms.
To start, why is IBS labeled a functional gastrointestinal disorder rather than an organic disease? And why do its flares seem so erratic compared with conditions that reveal structural damage?
The functional label means motility, sensation, and immune nerve signaling misfire, even though tissue architecture looks normal. Because imaging can't capture cellular signaling faults, patients see a healthy-looking gut, yet experience pain. The randomness reflects shifting immune and nervous inputs rather than fixed lesions.
Many listeners say a food they tolerated for years suddenly causes pain. How does stress create that sudden intolerance to an everyday meal?
A February 2025 study in gastroenterology showed that when food is eaten during psychological stress, the gut's immune cells tag that food as dangerous. Later exposures, even in calm circumstances, activate that threat memory, sparking pain. Stress acts like an unwanted save button in immune software.
Let's dig into that experiment. What did the investigators actually do, and what made the results so compelling?
They fed mice a common dietary protein, ovalbumin, while subjecting them to 10 consecutive days of controlled psychological stress. After a 5-week break, the same protein was reintroduced without stress. Only mice that experienced the stress-protein pairing developed visceral hypersensitivity and abdominal pain, proving the coupling, not either factor alone, rewired the gut.
You mentioned visceral hypersensitivity. Could you define that term for our audience?
Certainly, visceral hypersensitivity is a lowered threshold for pain or discomfort in internal organs. In the gut, normal levels of stretching, gas, or motility are perceived as painful because sensory nerves fire too easily. It's a hallmark of IBS and was replicated in the stressed mice.
Some might assume the reaction is simply a food allergy. Why is that interpretation incorrect?
When researchers injected ovalbumin under the skin, the typical swelling of IgE-mediated allergy never appeared. The response stayed localized in the intestine. That shows we're dealing with a gut-specific memory loop rather than a systemic allergic cascade.
Mast cells and IgE antibodies were identified as central players. How do they transform a benign protein into a pain signal?
During the stress food pairing, IgE antibodies specific to ovalbumin dock on mast cells lining the intestine. On re-exposure, those primed mast cells burst, releasing histamine, proteases, and cytokines. Histamine in particular makes nearby sensory nerves hyperexcitable, so routine digestion produces outsized pain.
Where does that ovalbumin-specific IgE come from? Is it generated systemically?
The evidence indicates local production. Plasma cells in the gut mucosa switch to IgE synthesis under the combined influence of stress hormones and antigen exposure. That localized IgE doesn't circulate widely, explaining why the reaction is confined to the digestive tract.
Histamine is usually linked to sneezing and red eyes. How did the team prove it also drives gut nerve sensitivity?
They collected intestinal fluid from stressed mice and applied it to healthy neurons in culture. The neurons fired rapidly. When an H1 receptor antihistamine was added, excitability dropped to baseline. Eliminating mast cells or IgE altogether erased hypersensitivity, confirming histamine's pivotal role.
The study reported heightened sensitivity throughout both the small intestine and colon. Does that match what IBS sufferers feel?
Exactly. Patients often report discomfort from the upper abdomen to the lower bowel. The researchers found stress-linked immune changes propagated along the entire gut, mirroring those widespread sensations rather than a single localized hotspot.
This work builds on a 2014 review that tied stress hormones to mast cell activity in IBS. What did that earlier analysis contribute?
The review showed psychological stress increases both the number and activity of mast cells. These cells migrate closer to mucosal nerves, and proximity correlates with pain severity. Stress hormones like corticotropin-releasing factor, or CRF, bind receptors on mast cells and nerves, amplifying pain signals and disrupting motility.
Cortisol, the body's main stress hormone, often stays elevated in chronic anxiety. How does prolonged cortisol exposure further erode gut stability?
Persistently, high cortisol thins the mucosal barrier, promotes dysbiosis, and slows epithelial repair. That leaves immune sensors exposed, keeping the gut in a hair-trigger state where modest stimuli provoke exaggerated reactions. Over months, the hyperreactive loop becomes self-sustaining.
Given that physiology, practical stress reduction isn't optional, it's essential. What foundational steps blunt cortisol surges and stabilize immune signaling?
First, establish predictable rhythms, balanced whole food meals, 7 to 8 hours of consistent sleep, and moderate daily movement, like brisk walking. Those basics align circadian hormones, support microbial diversity, and minimize cortisol peaks without imposing metabolic strain.
Diet often intersects with stress. How can food choices reinforce calming signals rather than ignite immune flares?
Emphasize unprocessed proteins, abundant colorful produce, and healthy fats while avoiding industrial seed oils that generate inflammatory oxidized metabolites. Consistent meal timing prevents blood sugar swings that mimic stress chemistry. Hydration supports mucosal integrity and smooth motility.
Breathing patterns and mindset also modulate the stress axis. Which techniques are both low-cost and evidence-backed?
Slow diaphragmatic breathing, 5-second inhalations followed by 5-second exhalations, engages the parasympathetic system within minutes. Cultivating optimism, expressing genuine laughter, or engaging in creative pursuits such as painting diverts cognitive resources from rumination and releases endorphins that counteract stress biology.
For those wanting extra tools, what practices have documented benefit?
Emotional freedom techniques, or EFT, combine fingertip tapping with focused statements to calm the amygdala quickly. High-quality sleep is a pillar. Keep the bedroom cool, dark, and device-free an hour before bed. Physical touch, even a short hug, raises oxytocin and suppresses the stress response.
Once stress is under control, how can listeners reinforce a resilient gut environment to prevent hypersensitivity from resurfacing?
Support butyrate production, a short-chain fatty acid that strengthens tight junctions and modulates immunity. Replace industrial seed oils with stable fats. Choose unrefined carbohydrates rich in resistant starch, and consider targeted Akkermansia supplementation to enhance mucus layer resilience and microbial diversity.
In essence, stress doesn't merely intensify discomfort, it rewires immune memory, pairing specific foods with danger signals and enlisting mast cells to drive pain. Addressing stress hormones, moderating mast cell activity, and nurturing the microbiome together open a path to durable relief.
Exactly. Effective IBS management focuses less on hunting for new food villains and more on restoring balance among the nervous, immune, and microbial networks. By integrating mindful lifestyle practices with gut-supportive nutrition, listeners can reduce flare frequency and regain confidence at the table.
That brings today's exploration to a close. We appreciate the time you've invested in understanding how psychological stress reshapes digestive physiology and immune memory.
Thank you for joining us on Dr. Mercola's Cellular Wisdom. We look forward to sharing more cellular insights in our next episode.
Thanks for watching. Subscribe now and click the notification bell so you never miss an update. See you in the next video.